everyone. In this video, we will be discussing about an example which is based on frustum of a cone. So, let's have a look at the example. An open metal bucket is in the shape of a frustum of a cone mounted on a hollow cylindrical base made of the same metallic sheet. The diameters of the two circular ends of the bucket are 45 centimeters and 25 centimeters. The total vertical height of the bucket is 40 centimeters and that of the cylindrical base is 6 centimeters. Find the area of the metallic sheet used to make the bucket where we do not take into account the handle of the bucket. Also, find the volume of water the bucket can hold and take the value of pi as 22/7. Now, we are required to find the area of the metallic sheet which is required to make this bucket. So, the area of the metallic sheet will include the curved surface area of the frustum, area of the circular base as well as the curved surface area of the cylinder. So, if we add the curved surface area of the frustum, area of the circular base as well as the curved surface area of the cylinder, we will get the area of the metallic sheet which is required to make this bucket. And we do not take into account the handle of this bucket. Now we are also required to find the volume of water the bucket can hold. And the volume of water is nothing but the capacity of the bucket. And we know that it is given by volume of the frustum of the cone. So let's look at the solution. We need to mark the dimensions first. So, the total height of the bucket is equals to 40 centimeters, which includes the height of the base of the cylinder. So, if we subtract the height of the base of cylinder from the total height of the bucket, what will we get? We will get the height of the frustum of this cone. So, the height of the frustum of the cone is equals to 40 minus 6, which is given by 34 centimeters. So, h is equals to 34 centimeters. Now, diameter of the first circular end of the bucket is equals to 45 centimeters. So, radius of the first circular end of the bucket will be given by 45 by 2 centimeters. So, R1 is equals to 22.5 centimeters. Now, diameter of the second circular end of the bucket is equals to 25 centimeters. But we need the radius. So, radius of the second circular end of the bucket will be given by 25 by 2 centimeters. So, R2 is equals to 12.5 centimeters. Now, height of cylindrical base will be given by capital H is equals to 6 centimeters. And we are also required to find the slant height. So, the slant height of the frustum will be given by L is equals to square root of h square plus r1 minus r2 square. By putting all these values, we will get our slant height, which is L is equals to 35.44 centimeters. Now, we are required to find the area of the metallic sheet, which includes the curved surface area of the frustum, area of the circular base, and the curved surface area of the cylinder. So, the area of the metallic sheet used will be equals to curved surface area of frustum of cone plus area of circular base plus curved surface area of cylinder. By putting all these formulas, we get pi r1 plus r2 into L, where r1 is the radius of the larger circular end and r2 is the radius of the smaller circular end and L is the slant height. Pi r square is the formula for area of the circular base, where r is nothing but the radius of smaller circular end and 2 pi rh is the curved surface area of cylinder, where r is the radius of the smaller circular end and h is the height of the cylinder. So, by putting all these values, we will get 4860.9 centimeters square. So, the area of the metallic sheet which is used is equals to 4860.9 centimeters square. Now, we are required to find the volume of the water which the bucket can hold, which will be given by volume of the frustum of the cone. So, the volume of the water that the bucket can hold, also known as the capacity of the bucket, will be given by 1 by 3 pi h r1 square plus r2 square plus r1 into r2, which is nothing but the formula for volume of frustum of the cone. Here R1 is the radius of the larger circular end and R2 is the radius of the smaller circular end and h is the height of the frustum. So by putting all these values, we will get our answer, which is 33,615.48 centimeters cube. But we need to convert this into standard form, and we know that 1 liters is equals to 1000 centimeters cube. So when 33,615.48 centimeters cube is divided by 1000, we will get 33.62 liters, which is the approx value. So we can say that volume of water that the bucket can hold is equals to 33.62 liters, which is the approx value. Now, bonus tip. We have learned that volume of frustum of a cone is equals to 1 by 3 pi h r1 square plus r2 square plus r1 into r2. Curved surface area of the frustum of cone is equals to pi r1 plus r2 into L. Area of the circular base is equals to pi r square. Curved surface area of cylinder is equals to 2 pi rh. And 1 liters is equals to 1000 centimeters cube. Thank you so much for watching.